Hi everyone, welcome to another session of XUBIS Explore the Depth. This is actually part 2 of the electricity generation classes that we have. In this class, we're going to discuss about how the generator or the power generation implementation is done practically. In the previous class, we discussed about the Faraday's law, the generator, various parts of the generator, and the induced voltage concept, and also a few functions that controls the output voltage as well as the frequencies, etc. Now let's have a very quick refresh about the certain concepts that we discussed. Generator is basically is transforming the kinetic energy to electric energy, which is explained by Faraday's law, and we call this as induced voltage. So all that we want to focus now is how the kinetic energy can be more formed in such a way that the required amount of electric energy is created. Right, we know that kinetic energy is basically energy formed by virtue of motion, which is basically the motion that we wanted to create at the rotor, right? So that's what the focus is on now. Now we know that an energy that we could call it as a prime mover, which basically acts as a source of energy for the rotor to rotate, which is then creates the electrical energy, and which can also be controlled by the governor. Anything that controls the prime mover energy transferred to the rotor, we can call that as a governor. Prime mover or this energy can be created by burning of fossil fuels, or by virtue of nuclear reaction, or by some renewable energy sources as well. If you look at if I do a certain arrangement where I heat the water inside this boiler in a high temperature, it's gonna create the steam, and the steam is gonna be with good amount of pressure, which can actually, if I keep my arrangement in such a way that the rotor is get triggered by this pressure of heat or by this pressure of steam, then I could rotate the rotor, which is then explained in this diagram. So the steam comes to this arrangement where it's kind of a wheel. The wheel is being rotated by the pressure of this steam, and then when the wheel is directly connected to the rotor shaft, which is then eventually rotates our rotor, right? So this high pressure of steam can rotate the rotor, which then creates the electricity. So anything works on this concept, we call this as thermal power plants, right? So it's basically the thermal power plants can be, or the heat can be generated by fossil fuels, right? Or it can also be generated by a natural gas, right? So there are multiple ways. Fossil fuels itself, there are various type of coals that is being widely used to create this heat, and then the steam generated out of this heat is basically gonna acts as the prime mover for the rotor to rotate. Such plants is called as thermal power plants. Other way to do the same or the similar pressure creation is basically to depend on nuclear reactors. Nuclear reactor is such an arrangement where a chemical reaction, basically the fission of uranium atom, creates a lot of heat. It's create a lot of energy. So here if you look at this particular diagram, there is a control rod, there are nuclear reactor, which is then goes to the water, and the steam is generated by this energy release of fission of uranium atom. This steam is gonna get connected to the steam turbine in which the rotor is connected, and then the rotor triggers the motion, and then it generates the electricity. Plants where we depend the nuclear reaction, we call this as nuclear power plants. So we discussed about two types. One is thermal power plants, and second is nuclear power plants. As I want to remind that all of these power plants are named after what kind of prime mover they use, what type of technology they use for the rotor to rotate. Third type of power plants is basically depends on renewable sources. What are the renewable sources? It's basically the one that's uses for creation of electricity is basically wind, the water pressure, and then the solar. Renewables the most widely used and historically developed one is basically hydroelectric power plant. Solar goes in second place in terms of the power capabilities as well as the power delivery capabilities as on today, whereas wind is also becoming much more crucial for certain countries where the wind acts as a source of prime mover. In a hydroelectric plant, what they have is basically the pressure is generated by either source of elevation differences of water, where the high amount of water is kept in a dam and then it opens by this control gates, and it allows us to control the flow of the water, and then the given to the turbine, and turbine basically rotates the rotor, and then it's the rotor of the generator and it creates the electricity. And in some places it is also utilizes the river flow pressure. It's not necessary that always it need to be at certain different elevations, but some places they also uses the river flow pressure. um, Now, in terms of hydroelectric, there are again two types, the large ones and small ones, depending upon the amount of wattage they produce. The picture that you see here is basically the world's largest hydroelectric power plant in China. There is Three Gorges hydroelectric station. The capacity of this particular power plant is basically 22,500 megawatt. The other types is the wind turbines or wind power plants, in which the large turbines are rotated by the force of wind or air, and in which again arrangement is done where the rotation motion by the wind is converted to the is used to run the rotor, and then it creates the required amount of electricity, which is mainly used for household application, and it is also been now been used for factory kind of applications, and it is getting very famous these days. The last one that I want to discuss today is basically solar power plants or solar power generations. Now, in this is probably the only one which doesn't depend on our generator. Instead, it depends on a photo cells or the solar cells. As you allow the solar cells to get the sunlight on that, it excites electrons and it creates the electricity. So what you need is all to give a sunlight to the solar cell, and it's gonna give some voltage. With respect to the amount of sunlight, the amplitude of the electricity is gonna change. Way that it gets us is DC, but in our house and household applications we need AC to run, right? So we use a certain power electronics setups, or we call this as inverters or grid tied inverters, etc. And power electronics machines or equipments to convert this DC to AC in the max in such a way that the energy lost during the conversion is very less. These are the various types of power plants and power generation methods that we discussed. So the first one what we discussed was the thermal power plants, and then nuclear power plants, and then renewable power plants, in which we discussed about hydroelectric power plants and wind and also solar. Solar is the odd one out, where we don't use the principle is not to utilize the kinetic energy and then transform to electrical energy. Instead, it works on a concept called photoelectricity, where you don't need a generator or mechanical energy. Instead, sunlight is basically applied to the photoelectric cells, which then excites a current, right? So these are the fundamental types of power generation methods. Now we know that the power generation has been done in multiple ways. Let's look at some of the statistics. How are we doing these things in India? So if you look at this diagram, the number one source where India depends is basically coal. Coal is nothing but the fossil fuel, right? Or it's a thermal power plant. India have totally more than um, 399 power plants, thermal power plants. Out of that, coal has got major share, and some of them they also use the natural gas and other type of prime mover methods. The second largest is basically the hydroelectric power plants. In hydroelectric power plants, India's got 197 hydroelectric power plant. Coal is actually the largest, where Jharkhand is actually our largest coal mining state. That's where we get maximum coal. Probably this is one of the place where India beats US. So in terms of world's largest coal sources, China is the leading one. Second is India, and the third is United States. So we have large dependency on the coal or the fossil fuels. In fact, the lignite is also a type of coal. Brings us to the end of this particular class. So in order to summarize, we discussed about how the electricity is generated. So it's basically the generator is what we discussed. We discussed about its parts. We discussed about the rotor. We also discussed about the stator. We understood that complete generator is run by prime mover, multiple classifications of generator plants or the power plants. We have thermal, we have hydroelectric power plants, we have solar, we have wind, we also have nuclear power plants, etc. Now all of this was about generating the electricity. So if you recall our previous class, we discussed the relation between electricity and electronics. Now once the electricity is generated, there is a very well equipped distribution as well as transmission, um, uh, transformers as well as the transmission lines, etc., to get the generated electricity to our homes and factories and shops, etc. Now that we have got the electricity is finally arrived at home. Electricity is generation is also now discussed. Now next is the how to utilize this, how to utilize electricity, right? So utilization of electricity is what we call it as electronics, and we're going to discuss the fundamentals of electronics in the coming sessions. Stay tuned. Thanks for watching this. Let me know your feedbacks and questions, etc., in the comment box. Have a good day.